Hello, viewers, and welcome to our discussion, which is about evaluation of portfolio performance. And in this video, we are discussing several portfolio performance measures, among others, Treynor'S measure, Sharpe'S measure, Jensen's measure, appraisal ratio measure, information ratio, and Modigliani and Modigliani, which will be abbreviated as M squared. In this video, I will show you how to calculate the alpha, the Treynor, Sharpe'S, and Modigliani and Modigliani M squared. In the subsequent lessons, I will show you how to calculate appraisal ratio and information ratio. I'll try as much as possible to avail more lessons relating to evaluation of portfolio performance. This video is ideal for students who are taking advanced financial management chapter 2, which is on portfolio theory and analysis. My name is Mr. William of Fatima Institute, Center for CIFA Studies. We are based in Bika. In case you need an assistance relating to your studies, my numbers are 0727871093. I'm also a publisher and an author, so in case you need books for your studies, you can contact me directly on that number appearing on the footnote. That is 0727871093. Remember to subscribe to our video, make a comment, like our video, so that you can get the updates as and when we upload these videos in our YouTube channel. Get these videos from our YouTube channel, Fatima Institute. Now, before I go straight away to the calculation, because we have discussed on the theory part of these performance evaluation measures, we've discussed what alpha is, what Treynor is, what Sharpe'S is, and what Modigliani and Modigliani is all about. So I just focus on the calculation part of it. However, before I take the calculation, I wish to show you the formulas that we will be using when calculating these particular items. So note here, with the Treynor's measure, you'll be taking the return or the expected return minus the risk-free rate divided by the beta. For Sharpe'S, you'll be taking expected return minus risk-free rate divided by standard deviation. See, the difference between Treynor and Sharpe'S is only with the denominator. Whereas for Treynor, we divide by the beta factor. The Sharpe'S measure, we divide by the standard deviation. As I've just noted there, that the only difference between Sharpe'S and Treynor is with the denominator. Whereas with the Treynor'S, we divide by the beta factor, with the Sharpe'S we divide by the standard deviation. The Modigliani and Modigliani, or the M squared, you will be taking the risk-free rate plus the Sharpe'S ratio times market standard deviation. So note those formulas because I will be using them as I take up this particular question for the sake of elaboration. We take together one question here and then I'll give you your exercise. If you need this book, which is more detailed, you can just call my number and I will supply the book to you. Example, let's have an illustration here. The data in the table below has been collected to appraise the performance of 4 asset management firms. The performance appraisal data is there. We have Fund 1, Fund 2, Fund 3, Fund 4, and the market index. Expected returns for Fund 1 up to Fund 4 is 6.45%, 8.96%, 9.44%, 5.82%, and the market index is 7.60%. The beta factor for funds 1 up to 4 is 0.88, 1.02, 1.36, 0.80, and the market index is 1.00. The standard deviation for Fund 1 up to 4 is 2.74%, 4.54%, 3.72%, 2.64%, and the market index is 2.80%. The risk-free rate of return for the relevant period was 3%. Required, calculate and rank the funds using ex post alpha. Number 2, Treynor'S measure. Number 4, Sharpe'S ratio. And number 5, I think number 1 was you use ex post alpha. Number 2, you use Treynor'S measure. Number 3, you use Sharpe'S ratio. And number 4, you use Modigliani and Modigliani. Let's take up the solution. So you arrange your work that way. You start by showing the evaluation tool, whereby you have the alpha, then Treynor, Sharpe'S, and Modigliani, or MM, or M squared. Now for Fund 1, alpha, to calculate the alpha, one important thing that we should know is that we will be using the expected return for the alpha. Like for example, for Fund A, you can see we are using 6.45, which is here, but we are minusing 7.05. The only difficult part is how to calculate the 7.5. Now, I want you to understand how to go about that. Just shift on to these explanations which we have given there. Workings for alpha. What you'll be doing is that you'll be taking the risk-free rate and then you plus the beta factor into brackets. Then you take expected return on the market and then you minus the risk-free rate, and then we have explanations down here. So you can pause your video and then you study what we have tried to explain here. Now, since we are saying that alpha will be taking 6.45, which is the return, then minus, what are we minusing? What are we minusing? That's the question. So to calculate the 7.05, I've shown you here our workings. As we have said, you'll be taking the risk-free rate, because you're being told that the risk-free rate of return for the relevant period was 3%, we are trying to see where we got 7.05 from. So we take the risk-free rate of 3%, then we plus the beta for fund A or for fund 1 is 0.88. So then that beta you put into brackets, then you take 7.6, which is the market index, the return for the market index, which is here. The return for the market index is 7.6, and then you minus the risk-free rate of 3. So you will have gotten this portion here, which we are referring to as the expected return on the portfolio. So to calculate the ex post alpha, this is the formula, but calculating this portion here is the one which is a little bit tedious, because by the end of the day, we will need to take the return, the expected return, which has been given, and then you less the expected return of the portfolio, which is calculated that way. So you can see what we have done here, because we are saying the alpha for fund A is given by 6.45, which is the return, then minus 7.05, and that is how we have gotten 7.05. That is the risk-free rate plus the beta factor into brackets market index, you minus the risk-free rate, and you get 7.05. So when you see the 7.05 here, that is how we have calculated that, and therefore the alpha for fund 1, is negative 0.60%. For fund 2, the alpha for fund 2, we do the same. It is the expected return 8.96, which is here, minus 7.69. But how did we get 7.69? Just the same concept that we have used to get 7.05. You take the risk-free rate plus beta. The risk-free rate, we have been told, is 3% plus beta factor for fund 2, which is 1.02. Then you multiply by into brackets. Now this part does not change, will be the same, because we are taking the return for the market index, or the return for the market index 7.60, you minus risk-free rate, and then once you work out that, you get 7.69. Therefore, when you come to fund 2, you'll be talking about 8.96, which is the expected return. Then you minus 7.69, you get 1.27. Fund 3, the same. We take expected return 7.44. We do the same. We take the risk-free rate of 3%. Then we plus the beta factor of 1.36 into brackets. And then we take 7.6 and you minus 3, the risk-free rate. And we expect something like this, 3% plus 1.36 into brackets 7.6 minus 3, and you get 9.26. Therefore, our alpha will be, for fund 3, will be 9.44 minus 9.26, we have 0.18. Fund 4 will take 5.82. Remember, we are calculating the alpha for each fund. 5.82, we follow the same concept. We take 3%, which is this risk-free rate, plus the beta factor. This is a beta 0.80 into brackets 7.6. You minus the beta, you minus the risk-free rate of 3%. What you get is 6.68. What you get should be 6.68. So that is what you less. So we have worked out that. That is very clear. So alpha for fund A, negative 0.60%. For fund B, 1.27. Fund C, 0.18. And fund 4, negative 0.86. Ranking them, you start with the highest. Fund 1 is ranked number 1, followed by fund 3, followed by fund 1, and the last is fund 4. That's how we calculate the alpha. It is also called Jensen. So note that, that's important point, that the alpha is also known as the Jensen alpha, the Jensen alpha. Now let's move on to Treynor'S measure. Now Treynor'S measure, we've said Treynor'S measure is given by expected return minus risk-free rate over beta factor. Therefore, for fund A, we take 6.45 minus, you're saying you minus the risk-free rate. The risk-free rate is 3%, then divided by the beta factor. The beta factor is 0.88. So Treynor'S measure for fund 1, 6.45 minus 3 over 0.88, you get 3.96. For fund 2, the expected return is 8.96. We minus risk-free rate of 3 over 1.02, which is the beta. Fund 3, 9.44 minus 9.44 minus risk-free rate of 3 over 1.36. And lastly, fund 4, 5.82 minus 3 over 0.80, and we have 3.53. Ranking, you start with the highest. The highest is fund 2. Fund 1, fund 2, that is the highest is fund 2. So fund 2 will be ranked number 1, followed by fund 3, followed by fund 1, and then fund 4. That's how you calculate Treynor'S measure. That is expected return minus risk-free rate over beta factor. That's Treynor'S. We go to Sharpe'S. We have said the difference between Sharpe'S and Treynor'S is only with the denominator. Whereas with the Treynor'S, we divide by beta factor. The Sharpe'S, we divide by the standard deviation. So basically, the numerators will be the same. As here you can see 6.45 minus 3, 6.45 minus 3, 8.96 minus 3, 8.96 minus 3, 9.44 minus 3, that they are the same. But whereas for the Treynor'S, we are dividing by the beta. For the Sharpe'S, we'll be dividing by the standard deviation. Standard deviation measures risk. Beta measures the systematic risk, that risk which cannot be diversified fully. Now we'll be taking Sharpe'S, so we'll be taking the expected return minus risk-free rate over the standard deviation. For fund 2, you divide by 4.54, which is the standard deviation. For fund 3, you divide by 3.72. For fund 4, you divide by 2.64. And you'll have your Sharpe'S ratios here. For fund 1, 1.26, fund 2, 1.31, fund 3, 1.73, fund 4, 1.07. Ranking, you start with the highest. Fund 3 is the highest, followed by fund 2, followed by fund 1, and then fund 4. The last is Modigliani and Modigliani, and you have said that is given by risk-free rate plus, into brackets, Sharpe'S ratio times market standard deviation. For fund 1, you take the risk-free rate, which is 3%, plus, into brackets, Sharpe'S, the one you have calculated here, 1.26 times the market standard deviation, and this is the market standard deviation. So it will be multiplied by 2.80. 2.8 is the same throughout because we are operating in the same market. So you can see you'll be taking risk-free rate 3%. 3% or 3 is just the same. Plus, into brackets, Sharpe'S, the one you have calculated up there, 1.26 is 1.31, this one here, 1.73, this one here, 1.07, this one here. And once you work out that, you have your Modigliani and Modigliani measures or ratios, and you rank them starting with the highest, which is fund 3, followed by fund 2, followed by fund 1, and then fund 4. Have we answered that question? I think we have answered that question comprehensively. The major thing here is for you to understand the formula. The most important thing here is to understand the formula that we are using. Now there are some notes here which I've given you. You can just pause your video and you understand what I'm trying to explain there. Note that the alpha and Treynor'S measures give the same rankings, and the Sharpe'S and Modigliani and Modigliani measures give the same rankings. However, when comparing the alpha and Treynor'S rankings to the Sharpe'S and Modigliani and Modigliani measures, funds 2 and 3 trade places. Fund 2 has a much higher total risk. Total risk is measured by standard deviation than fund 3, but has a much lower beta. Relatively speaking, for fund 2's total risk, a smaller proportion relates to systematic risk that is reflected in the low beta. Compared to fund 3, it must have a bigger proportion of risk relating to non-systematic risk factors. Hence, fund 2 does better in the alpha and Treynor'S measures as they only look at systematic risk, that is beta. It fares less well when it comes to the Sharpe'S and Modigliani and Modigliani measures that consider total risk. I think I've discussed about how we calculate the alpha. We have explained here this formula here. Anything else here is just a discussion of what we have done. You can just pause your video and then you follow what we have discussed there. Some important notes here concerning the summary of this discussion is Alpha and Trainer both measure risk as systematic risk. Remember, the systematic risk is that risk which affects all firms in the business environment, and as such, it cannot be diversified. Beta is used to measure the systematic risk. The unsystematic risk is that risk which affects a specific firm in the economic environment, and for that reason, it can be diversified. It can be diversified, and thus it is measured by use of standard deviation. They will agree in that a manager will with positive alpha will have a trainer in excess of the market trainer. They may not always agree in relative ranking. A manager with the highest alpha may not have the highest trainer. Point number 2, superior or inferior Sharpe will mean superior or inferior. Modigliani and Modigliani both measures risk as total risk or standard deviation. Both alpha and trainer are criticized because they depend on beta and assumptions of the CAPM. The criticisms include 1, the assumption of a single priced risk rather than some form of multi-factor risk pricing, and the use of a market proxy such as S&P, that means a Standard & Poor 500, to stand for the market. Rowe's critique shows that small changes in what is assumed to be the market can significantly change the alpha and trainer calculations and even reverse the conclusions of superior or inferior performance and rankings. Number 4, measures like Modigliani and Modigliani that use a benchmark are also subject to the criticism. The benchmark used may not be precisely replicable. As a related issue, transaction cost to replicate the market or a custom benchmark are not considered. Number 5, any ex-post calculation is a sample of true results, and actual results can be different in the future. Even if results do reflect true manager skill, the manager can change approach or style in the future. Alpha, Trainer, and Sharpe'S are the more widely used measures. And lastly, also remember that the highest relative return measure does not necessarily mean the highest return. For example, a very low risk portfolio with low beta or standard deviation could have a higher alpha and Sharpe, but a very risky portfolio with lower alpha and Sharpe can still have the higher absolute return. Now there was a question there, but it moved on question page 150, which is not near, but I'll give you that one next time, or if you have my textbook, you can just have that example there. Now let me give you an example as we wind up. Remember, this is one of my books which I have published. I'm a publisher, I'm an author, so many books I've written. So most of these classes, whether physical classes or online classes, we use our own materials. So I'll give you this one as your assignment. You can look at it. Amos Odongo is reviewing the performance of his largest asset, Fair Mutual Funds, for the month of December 2014. He obtained the following data to undertake the task. You have expected return for Fair Mutual Fund 14%, The market return 12%, beta coefficient 1.2, for the market is 1.0, standard deviation 28% and 26%. The return on government treasury bonds is 5%. So anytime you come across treasury bonds or treasury bills, it means that you are dealing with risk-free rate. Risk-free rate means those securities where there is no risk of default. So the government does not default. So treasury bills and treasury bonds are riskless. So the 5% that you see there is risk-free rate. Required, evaluate the performance of the fund using 1. Treynor'S ratio, number 2. Sharpe'S measure, number 3. Jensen's alpha, and then number 4. Explain whether fair mutual outperformed the market using the results obtained in 2B above. Now, well, because this is quite simple, we say Treynor'S ratio is given by expected return minus risk-free rate over beta. You can see we are taking 14, which is the expected return. We minus the risk-free rate, 5%. We divide by beta, which is the 1.2 beta coefficient, and the Treynor'S ratio is 7.5. The Sharpe'S ratio, the difference is that with the denominator, whereas for Treynor'S ratio we divide by beta. For Sharpe'S ratio we divide by standard deviation. Remember, the difference between the beta and the standard deviation is that beta measures the systematic risk, that risk which cannot fully be diversified, whereas the standard deviation measures risk associated with the unsystematic risk. So up to that, I think I should leave the rest to you. You can take, so I've done for you Treynor'S ratio and Sharpe'S measure. Now try Jensen's. I've told you Jensen's is the same as alpha. It's the same as this question which we have just done there, where you are calculating the alpha this way. So when you some books talk of alpha, others talk of Jensen's measure. So when you see Jensen's measure, it means alpha. So the name alpha and Jensen's measure are used interchangeably. So can you try that? Now let me just assist you with the solution so that you can do your own solution, and then you compare with our solution. Maybe we are wrong or we are right. So the question starts from there. You can pick your question from there. Where Amos Odongo is, and then the question is then calculate Treynor'S ratio, Sharpe'S measure, Jensen's alpha, then explain whether fair mutual outperformed the market using the results obtained above. So go through, attempt the question. First attempt the question, and then you can check our solution. So that is it for today, and told you my numbers are just there: 0727 871093. My name is Mr. William. Fatima Institute Center for CIFA Studies. We are based in Thika Town. If you need classes, physical classes, or online classes, feel free to contact us through the numbers appearing in the footnote of that particular book. I'm also a publisher and an author. So if you need my books, you still call the same number. We make arrangements on how you can get assistance. So that is enough for that. I'll still take another question next lesson, and I upload so that you continue having sufficient, appropriate, necessary, and helpful revision materials for your examination or for the general knowledge in finance. Thank you for watching. We meet again. Have a good day.